Okay, so Mr. Roach, this is problem number 3. So what I did is, after I found my one solution system, I went and turned that on its head after getting the integer values, and I made it into an inequality. So what I have here, I have my ellipse equation, x squared over 25 plus y squared over 16 is greater than or equal to 1. And then I had y is less than or equal to x squared plus 4 for my parabola equation. So, if you think about this conceptually, the reason why I did this is because I thought that if x squared over 25 plus y squared over 16 is greater than or equal to 1, everything greater than the values inside of my ellipse would be contained in the solution set. And if you look at the parabola equation, y is less than or equal to x squared plus 4, everything less than the values including the parabola or inside of that conic would contain the solution sets. So I represented this with blue and yellow. Blue and red. So everything outside of my ellipse was indicated in blue, and everything outside of my parabola was indicated in red. And so I showed the overlap right here when I had everything intersecting. So all of this region, the region that's outside of both conics, is my solution set. Now, to verify my work, I used some of the points. First, I started with a point inside the ellipse, the origin. So I plugged that into my original parabola equation, and I got 0 to be less than or equal to 0 plus 4, because y is less than or equal to x squared plus 4. I just plugged in 0 for x and 0 for y, and I got 0 to be less than or equal to 4, which is so far so good. But then, when I plugged in my 0, 0 point into the ellipse equation, I found that after plugging 0 into x and y, I had 0 squared over 25 plus 0 squared over 16 greater than or equal to 1, and it is false. 0 is not greater than or equal to 1, so this solution is not true. So this is not part of the solution set. And so I knew that everything inside of the ellipse would not be indicated in the solution set. So now I tested the parabola. So I got the point 0, 7, so that would be inside of the parabola. And so I went and I tested it back into my original equation. So I plugged x and y, 7 for y, 0 for x. 7 is less than or equal to 0 squared plus 4. Right there and then, I know 7 is not less than or equal to 4. 7 is obviously greater. And so when I went back and plugged it into my other equation, 0 squared over 25 plus 7 squared over 16 is greater than or equal to 1. I got 0 plus 3.0675, and 3.06 is greater than or equal to 1, but it doesn't matter because 7 is less than or equal to 4. So then I went with the final point that I could. Everything inside of the parabola, the point inside the parabola did not work. The point inside the ellipse did not work. So all I have left to check is the region outside both conics. So what I did, I set a point at 10, 10, which would be located around this area right here. And so I plugged that into both my equations. And so I got 10, plugged in 10 for y, 10 for x. So 10 is less than or equal to 10 squared, which is 100, plus 4, which gets me 104. This is true. And then when I plugged it back into my ellipse equation, I found that 10 squared over 25 plus 10 squared over 16 is greater than or equal to 1. This is true because 10 squared over 25 gets me 4, plus 10 squared over 16, 6.25, which all adds up to be 10.625, which is greater than or equal to 1. We're good, and that's my solution set.